Hello, and welcome to the Arcserve Cloud demo walkthrough. The agenda will cover a quick introduction to the Arcserve Cloud service as well as the implementation topology. Also, a detailed demo will cover all steps to configure the Arcserve Cloud service and validate the replication to the cloud. And finally, different Arcserve Cloud recovery options will be shown, as well as some plans for protecting servers running in the Arcserve Cloud. So what is the Arcserve Cloud Service? The Arcserve Cloud Service is a single, fully integrated solution for backup, disaster recovery, and long-term retention, with secure offsite disaster recovery without upfront investment and maintenance of secondary sites, infrastructure, and personnel, remote virtual standby for emergency application failover and failback, long-term cloud backup storage as an alternative to local disk or tape for regulatory compliance, global source-side deduplication and WAN-optimized replication for highly efficient use of backup storage and available bandwidth, rapid deployment via a jump-starting offline synchronization service, and ease of management with 24/7/365 support. Now, let's look at a topology diagram. Here is a typical customer site running Arcserve UDP where backups utilize the local RPS server. Next, the Arcserve Cloud is provisioned and access information is provided to the customer. At this time, a link is provided for the customer to set their encryption password for the Arcserve Cloud data store. The Arcserve Cloud, in simplest terms, is Arcserve UDP running in the cloud. A UDP recovery point server will be provisioned in the cloud, with a share plan to allow replication of selected node recovery points. This saves provisioning and configuration of the UDP server in the cloud, which greatly simplifies the setup. Once the Arcserve Cloud service is configured, local recovery points are replicated to the Arcserve Cloud. Customers will be able to access the Arcserve Cloud console to check logs, change the retention settings for daily, weekly, monthly, and custom backup now jobs, as well as perform recovery from the Arcserve Cloud. For customers whose initial replication of recovery points may prove challenging over the WAN connection, there are two options. First, use the Arcserve UDP Jumpstart utility with a removable drive and send the drive for import into the Arcserve Cloud. Second, create a new local UDP plan for backup and replication and move nodes into this plan over time to mitigate the transfer over the WAN. Once the recovery points are replicated to the Arcserve Cloud, there are three types of cloud recovery methods. 1. Mount recovery point. Using the UDP agent in the cloud, connect to the cloud RPS server to browse and mount recovery points. 2. Export data store. Opening a ticket with Arcserve support, an export of the cloud data will be arranged. The portable drives will be shipped to the customer to import locally using the Jumpstart utility. And the third method utilizes Arcserve UDP virtual standby in the cloud. Typically, a ticket is opened with Arcserve support, and a recovery console is provisioned and access provided to the customer. Using the UDP Cloud Console, recovery points are converted to virtual machines on the provisioned hypervisor server. These VMs can be started as part of a DR test or additionally configured to replace the local production servers. Note, Arcserve does offer a solution whereby this hypervisor server is available 24/7, eliminating most of the setup time at test or recovery. Okay, let's see how easy it is to set this up. After purchasing the Arcserve Cloud service, an email will be sent from Arcserve support that contains the access and credentials. As expected, the Arcserve Cloud hostname and console URL is provided along with a username and password. Note, there is also a link to change the encryption password for the cloud data store. The customer can use this link only once, and Arcserve has no way to recover this password, so ensure it is part of your recovery planning. So, the first thing to do is test connectivity from your Arcserve UDP environment to the Arcserve Cloud. Here, the first tab happens to be the local customer environment, and we open another tab in the browser and cut and paste the Arcserve Cloud URL there. You will likely get a certificate warning, and you can install the certificate or proceed anyway. If the login for the UDP Cloud Console appears, you're ready to go. Enter the username from the email and cut and paste the rather long and secure password and click Login. And here you are connected to the Arcserve Cloud Console and can skip the welcome as the Cloud RPS server is already configured. Some housekeeping here pertaining to this video. Note that we use the same browser for the Cloud Console and local UDP console. An easy way to keep track of this context during the video is to note the user. Here, the Cloud user indicates this is a Cloud Console. The local console user will be administrator. Now, we switch to the first tab, which is the customer's local UDP console and login. Select the Resources tab, and we can see a local source node. Next, select All Plans, and here is the local plan used for this demo. Click on Arcserve Cloud. This Modify Plan view shows that node JES-2K8R2-4 is protected by an agent-based backup. And the Destination tab shows the local RPS server and data store, as well as the backup job's session password. Note, this session password will be needed when accessing data in the Arcserve Cloud. And here we see the Schedule tab has daily backups and a retention policy for the local RPS server for daily and custom backups. Here, the Add button allows the addition of weekly and monthly backup schedules, as well as merge and throttle for the local backup job. For this demo, we are modifying an existing job. Most customers would create a new plan and move nodes over time to regulate the data replicated to the Arcserve Cloud. If this is a new job, it is recommended that you run a successful backup to sanity check the job before adding the task to replicate to the Arcserve Cloud. Use Add a Task to add Task 2. And here choose Replicate to a remotely managed RPS. Also note there are no source settings, as Task 1 Agent Backup produces the recovery point that is the input for Task 2. Now choose the Destination tab. Refer to the configuration email, and in the Remote Console field enter the host name, not the URL, of the Arcserve Cloud UDP console. Also, the username and password. It is recommended to cut and paste the rather long password. Now the protocol, which defaults to HTTP. Be sure to change this to HTTPS. And scrolling down, this network requires an internet proxy. This is similar to what a browser would use from a customer's network to access the internet. These values will vary, if needed at all, and the local network administrator should be consulted to provide the settings for your site. Once complete, validate with the Connect button. The settings are valid as the replication plan is now in the drop-down. This plan was retrieved from the Arcserve Cloud. By default, there is no replication or throttle schedule, so replication will start for each node after the backup job completes. Also, all available bandwidth will be used unless a throttle schedule is set. So that's it. Choose Save to complete the Modify plan, and when successful, is ready to go. Now, in the left pane, select All Nodes. Select the node and right-click on the row and choose Backup Now from the drop-down. We take the default incremental backup and choose OK. Moving to the Jobs tab, highlight the jobs in progress and the backup is underway. Following the backup, since there is no replication schedule, replication out to the cloud begins. Here are some details about the replication. Now, the replication is complete, and we can use the View Logs link to check the replication. As expected, this incremental job ID 27, replicated quickly. This is because data was replicated before and never removed from the cloud data store. Let's take a look at job ID 21, as that was the initial replication for this node. As you can see, session 1 is 88 gigabytes and it took about 14 hours. Obviously, the network bandwidth is the first thought, but remember this. This is the first node going to a clean data store, so deduplication is limited to the data on the node. If there were a similar node, same operating system, it is likely that 50% or more of the data is already on the data store, so hash index updates are all that's required. This results in sending much less data. Depending on the total size of the customer's data store, the jumpstart process can also be an option. The jumpstart process allows a drive to be attached to the local RPS server, and then a data store is created on the portable disk. Now, jumpstart can copy the data store, and when complete, the drives can be sent to Arcserve for direct import into the Arcserve Cloud data store. Another alternative is to regulate and monitor the data being replicated. Create a new plan with replicate to the cloud and move nodes over as bandwidth permits. As the data store grows, so will the change of deduplication. So again, benchmarks against initial replications may not indicate average throughput. And here we are scrolling up the log file, and you can see the incremental sessions being replicated. And finally, the replication completes. Note, this replication is WAN friendly and interruptions are expected. For this reason, the replication process can quickly determine where it left off and continue from there. Now, we switch back to the UDP Cloud Console tab. Again, we see the cloud user logged in. Under the resources, we can see the replicated node along with the Arcserve Cloud node. Select all plans and check the plan named Replication. Again, this plan was set up and shared automatically when the Arcserve Cloud was provisioned. This presents the Modify a Plan UI, and here the source is the customer's RPS server, where the data is replicating from. Here you can see the destination, which is the Cloud RPS and data store. And here we see the schedule on the Cloud replication task. Note, only daily and custom backups are replicated and retained. Only if the customer's local job has weekly and/or monthly schedules can the retentions for both be set here. Also note, these settings can differ from the customer's data store. Typically, the customer will retain more copies of current recovery points, and the cloud may retain less daily recovery points and more weekly and monthly, whatever suits the customer's needs. After choosing Cancel, since we did not change the plan, we return to the Resources tab. Now choose Recovery Point Servers. Highlight the data store. Here, we choose Browse Recovery Points. Also note that this is where RPS Jumpstart can be initiated from. Here you can see details about the nodes and their Arcserve Cloud recovery points. So that's it. At this point, you could continue to add nodes as bandwidth permits or decide to use Jumpstart to facilitate the initial data replication. So now let's look at the cloud recovery that's always on. Mount Recovery Point provides a basic node browse and mounting of a drive from a selected cloud recovery point. Start by connecting to the Arcserve Cloud agent using port 8014 and use the same cloud user credentials. Here is the agent. It is not used for backup, thus the summary status is expected. Choose Mount Recovery Point from the right pane. Use the Change button to select the Cloud RPS data store. Provide the connection information for the recovery point server and be sure to select HTTPS. Then refresh. You can see the data store and also the protected nodes on the right. Select a node. And here you can see the calendar and volume information. Be sure to mount the selected drive to Z. Only data on the Z drive is presented for SFTP access. As mentioned earlier, your recovery points are protected by the local backup session password. If you don't have it, it's a big problem. Please make sure all session encryption passwords are documented as part of your DR plan. Complete the password and click OK. and the drive is mounted to Z as seen in the top pane. Keep in mind, this mount does consume resources and should be unmounted by the customer when finished. Now the customer can access this data via SFTP. So here is an example of an SFTP client, FileZilla. Here you can set up a site, but other SFTP clients may differ. Essentially, you need the host name for the Arcserve cloud and use port 37037. Be sure and double check the port. Also, select SFTP as the protocol for a secure transfer and the user is Cloud User. Click Connect. And the password for Cloud User is entered. And at the top pane you can see the connection. If there was a connection error, make sure the recovery point is currently mounted to the drive letter, Z. Also, be sure to check the complete node name and port, as well as potentially the user and password. Moving the UI, you can see I have navigated to the C drive for the mounted recovery point. File sizes and details are listed, so this is a great validation of the remote recovery point. Also, you can drag and drop files to transfer them if required. Again, this recovery option is always on, provided there is an Arcserve Cloud recovery point mounted to the Z drive. And don't forget to unmount the volume when finished. Some customers may opt to leverage off-site and compliance regulations to the Arcserve Cloud and plan to recover locally in the event of a complete failure. In this case, a ticket is opened with Arcserve support. An export of the customer's data is done to a removable drive and is sent to the customer. The customer can use Jumpstart to import the data to their local Arcserve UDP server and then use the recovery points for local recovery. Okay, let's look at another way to leverage replicated recovery points using virtual standby in the Arcserve Cloud. The first step here is to contact Arcserve support and open a ticket to have a recovery server running Hyper-V provisioned in the cloud. This should be the very first step in recovery. Note, some customers may choose to maintain this recovery server 24/7, and therefore these steps would essentially be completed once and everything would be ready to go. Start by connecting to the Arcserve Cloud Console. Since the Cloud Console did not perform the original backup, the replicated session passwords are not known and must be added. From the All Nodes view, right-click on the node and choose Set Backup Passwords. Here you can define multiple passwords as they may change over time. Save and navigate to All Plans. Select and modify the replication plan. Add a second task, Virtual Standby. The source is Task 1. Under Virtualization Server, select Hyper-V, enter the IP address, not the host name, and the Continuity Cloud username and credentials supplied as part of the provisioning. Also make sure that the HTTPS port is selected and clicked Connect. Success. Use the Virtual Machine tab for settings. Note, we will keep the default VM name prefix. This avoids confusing a production VM from a DR test instance. Scrolling down, the disk information is set and network settings can be accessed. Save the plan and note the details of Task 2 in the right pane. Pause and resume the plan. Select Yes. In this case, there is no connection to the production node, so the agent check fails. Click Cancel to continue. And the virtual standby task will run and convert all sessions in this plan to VMs on the Hyper-V server in the Arcserve Cloud. Here is a quick shot of the details as the job runs. As you can see, the local data transfer in the Arcserve Cloud is quite good. And here we look at the Cloud Console and see the completed jobs. Using the View Logs link on the right, we can see the details for the virtual standby job. Using Remote Desktop and the credentials to the recovery server, we can use the Hyper-V Manager to see the virtual machine, currently off. Now, using the Virtual Standby section in the left pane, select the node and choose Standby VM. Here, you can power on the virtual machine. No need to access the Hyper-V console, and it is a best practice to manage the virtual standby VMs using the console. Also, note the link to configure the VM network if desired. Checking the Hyper-V Manager, as expected, the VM is running. If the machine is to be accessed as part of a production network, a link to the pfSense firewall is on the desktop. Credentials were supplied in the provisioning email. And as you can see, the configuration options allows these VMs to be configured for access over the internet. In support of the best practice, we return to the Cloud Console, select the node and choose Standby VM, and use Shutdown to keep everything in sync. It is highly recommended that any and all of these recovery methods be tested and documented, especially when recovering using virtual standby. Having a detailed and proven recovery plan is much better than having an unused week of recovery time. Please consider completing a DR test as soon as possible. The last topic gives some insight into protecting a virtual standby node running in the Arcserve cloud. In this case, the virtual machine will change as the customer uses the system in production. For this reason, and to facilitate local recovery, a protection plan is required during this time. So again, we start with the Cloud Console on port 8015 and the Cloud User account. Now, add a plan to the Cloud Console. Let's call it DR Backup and make Task 1 Backup Host-Based Agentless. Choose Set Backup Proxy. The backup proxy is the IP of the Hyper-V server provisioned for recovery that should already be defined based on virtual standby. Choose Importing from Hyper-V once the backup proxy is set. Supply the IP and credentials for the Hyper-V server. And now the virtual machines are displayed. Select the virtual standby VM, provide credentials, and add to list, then save. The source is now complete. For the destination, use the Cloud RPS server and data store. Note, it is a best practice to remove the local production node from the local backup job. If it is started as part of troubleshooting at the customer site and the local backup starts, you may wind up with some confusing backups. The saved job is deployed. And now select the node from the All Nodes list and choose Backup Now. The job starts, and here are the details. Snapshot. Backing up disks. Notice the deduplication is 99.96. This is expected from a robust deduplication algorithm. Technically, we already have this node protected in the same data store, so the expectation should be near 100% deduplication. And finally, the bare metal recovery information is collected. And the Cloud Console shows the completed jobs. At this point, the planning can begin to recover the production virtual standby node back to the local server. The customer should create a final backup of the virtual standby node, then shut it down and plan an outage until the local recovery is complete. Open a support ticket with Arcserve to transfer this recovery point from the cloud using a removable drive. The customer can then use Jumpstart to import the recovery point and use BMR or Recover VM to complete the local server recovery. This concludes the walkthrough of the Arcserve Cloud Service. For more information on this and other exciting Arcserve technology, visit arcserve.com. Thank you.